Hello, everybody. Thank you all so much for coming. I'm so happy to see you all here. I know you had a lot of choices for places to be, so thank you for being here. Just to give you an upfront content warning, there's going to be a lot of JavaScript in this talk, so just to warn you. But yeah, hello everybody. My name is Joe. I am a developer advocate at Deno, and today I'm going to be talking to you about building an in-browser code editor that not only will syntax highlight the code that you're displaying, but also will actually run it in the browser, and you'll be able to execute it and see the output. But before we get started, I'd just like to know a little bit about you lot. So who here is a web developer? Okay, awesome. Who has heard of Deno before? Anybody used Deno before? Amazing, okay, awesome. So today we're going to be building with Deno, and I hope for those of you who haven't used it before, I can introduce some things that you might love. So let's dive in and build an editor. But first, let's talk about why we might want to build a code editor. So aside from it being a kind of cool project, there's a couple of reasons why you might want to do this. If you've got a company that offers an API or other developer tools, you might want to offer your developers an in-browser way to test out the functionality, to try out little code blocks as a way of improving your onboarding experience for developers. Or you might want to give them little code snippets next to the documentation so that they can try things out without having to tab between their own editor and the browser. Or if you're running a low or no code solution, having an in-browser editor can be an excellent way to offer your developers a little bit of extra functionality so they can dive in and actually add some of their own code without needing to swap out of your tool or your product. But running code that is written by other people presents us with a problem. We can't always trust the code that people are writing. We can't just execute any code that we allow people to write on our websites. Allowing third-party code is going to open us up to a whole load of security vulnerabilities. Malicious scripts might be stealing data. It could be possible to inject harmful code into our tools, and it's just going to compromise our users' security. So we need a way that we're going to be able to prevent malicious code from wreaking havoc on our own code bases. And not only that, but if you're going to be executing other people's code, you're going to need resources to actually run that code. So you're going to need CPU, you're going to need memory. And this could possibly, if they're running something particularly intensive, this could potentially impact the page load for your own site. So in order to build something that is going to execute third-party code, you may end up needing to provision a large amount of compute. You will probably need to install something like Kubernetes. Then you're going to need to build a sort of management API, which is going to make sure that only the correct shape of code is allowed to be deployed onto your cluster. Then you're going to need to make sure your container instances are secure. Then you're going to need to make sure that you don't run out of storage. Likely you're going to need an entire ops team to do this. And the truth is, writing this kind of thing can spiral into a potentially, millions of dollars worth of problem. And that's a pretty significant barrier to entry for folks that just want to allow people to execute little blocks of code. So with all of that in mind, how are we actually going to build this editor, and what are we going to need in order to do so? So first of all, we're going to need to write an app of some kind where we're actually presenting this in-browser editor. Somewhere where they can type in some code, a bit like JSBin or CodePen or any of these things that you've seen before, and a go button that they can press to execute the code. Then we're going to need some hosting, which we're going to run this on, and a place where they're going to be presented with a URL they can visit. Finally, we're going to need an application platform that we can actually run the user's code on, likely something with serverless functions. And without wanting to sound too much like a sales pitch or a shill, I work at Deno, and Deno offers all of these tools for us. So I'm going to use these, but you can, of course, use your favorite tooling. I think the Deno tooling offers a really great developer experience, and I hope you will see that too during this presentation. But of course, you can use the tools of your choice. So we're going to be building with Deno, but what is Deno? I asked you if you'd heard of it. Deno is an open source JavaScript runtime built for the modern web. It natively supports TypeScript out of the box, so we can just write TypeScript and run it immediately. We can write, the strongly typed code that we know and love without needing to install or configure TSC. The runtime also includes built-in tooling for things like linting and formatting. These all just come out the box. We don't need to install any third-party tools. And you might have heard of Deno. We've been around for quite a few years. Deno was actually written by Ryan Dahl, who was the guy who originally wrote Node. And Deno was this kind of apology to the JavaScript developers of the world. It was him taking 10 years worth of Node experience and saying, I can do this better second time round. You may have recently seen we launched Deno 2.0. We had a really great launch video. If you've not seen it, do check it out. And Deno works out of the box with all of your favorite tooling, all of your modern web tools. So we're going to build our solution using React to do our UI framework. We're going to use Vite to serve our project locally. And then we're going to write some TypeScript because we can absolutely just do that out of the box without needing any configuration. So that's what our app is going to be. We're also going to need to host our app online somewhere. And as I say, you can use any hosting tool that you like. I'm going to be using Deno Deploy, which is the easiest and fastest way to deploy Deno apps to the cloud. It's deployed within the Deno runtime, so it's going to be super fast for your Deno code. You can deploy with a single GitHub action, which makes it super easy. And Deploy has a very generous free tier, so do check it out. And the final piece of our puzzle, as I mentioned, is we're going to need some sort of serverless functions. So on top of Deno Deploy, we have a set of capabilities which are designed for securely running third-party code. And the whole idea is it's built with this idea of building sandboxes in mind, and we call it subhosting. What it is it's a tool that allows developers like yourselves to offer cloud computing services to your own customers. So you can run code written by your own customers without having to worry about the infrastructure or the scalability. We've done all of that for you. Subhosting supports JavaScript and TypeScript. It's optimized to be super fast. So we're going to be able to run this code, execute it within milliseconds. So with all of this in mind, let's actually build out this app. So the first thing that we're going to need to do is we're going to need to set up Deno. Super easy. You can install it with Brew, with curl, with Chocolatey, however you like. And Deno has a VS Code extension, which is going to do all your nice syntax highlighting and code completions and all of your hinting and type warnings, that kind of thing. Deno has a tool that will set up a basic project for you. So Deno init and then the name of your project will set you up with a very basic JavaScript project. This is going to contain a main.ts file, a test file, and a Deno JSON file. And if you're coming from Node, your Deno JSON file is very similar to your package JSON. It's where we're going to configure the project. The main TS is going to be our entry point, and then Deno really believes in writing tests and writing good tests. So Deno has a test runner built in. Again, we don't need to install anything. It just comes with Deno. So Deno is going to set up a test file for us as well to encourage us all to be writing tests. Next up, we're going to install the dependencies that we're going to need. So I said we're going to use React. We're going to use React Router to do our routing. We're going to use Vite to serve this project locally. And finally, we're going to use Prism.js, which is going to do our syntax highlighting for us in the editor. And we'll talk about that a bit later on. Next up, we're going to add in a new script into our Deno JSON file, and this is what we're going to use to start up Vite. Because Vite is written with Node in mind rather than Deno, it's going to expect a Node modules directory. Now, Deno doesn't do a local installation of your dependencies. It uses a global cache instead, which sort of keeps your project folder a bit neater, in my opinion. So by default, Deno won't set up a Node modules directory, but because Vite expects it, we're just going to use this little extra flag here just to say, please set up a Node modules directory for me. And then we've got this -a here. So in this line, Deno is saying allow permissions to sensitive APIs. And Deno comes with this whole permissions model. We're all super used to using third-party modules. We kind of just allow them to run rampant in our projects. We don't know what they're accessing. We don't know, what permissions we're giving them. So Deno has a whole load of permissions flags which allow you to specifically say, you can have environment access, you can have network access, you can have read or write access. It just keeps you a little bit safer, especially if you're using a third-party dependency that maybe you don't trust or you don't know exactly what it's doing. It's also really nice if you don't include the -a, Deno will prompt and ask you, do you want to allow this thing to have access? And it'll actually show you which dependencies are asking for what access. It's just kind of, it's a bit of a different mindset from Node, which is more of a sort of wild west of permissions. This is more, no, I'm going to allow this, I'm going to deny that. But when you're in local development mode, you can just use -a, which is just have access to everything. We don't recommend using that when you're not in local development mode, so absolutely make sure you're applying the right permissions. So our complete Deno JSON file is going to look like this, and then you can hopefully see it looks a lot like your package JSON. We've got our imports, which are our dependencies, and we've got our tasks, which are our scripts. So next, let's look at the structure of how we're actually going to build this project. So the directory structure we're going to need is going to look like this. And let's assume that we've created all of these files and folders ready to go. The important thing to note here is that we've split it up. So we've got a client directory and we've got a server directory. And the client directory is where we're going to build our React app. And the server directory is where we're going to start building out the APIs. We're going to build a nice simple HTTP server, which is going to also serve the React app. So let's jump into, in fact, let's first look at the UI of what we're going to build. So please excuse my basic ass UI design skills. But this should hopefully illustrate what it is that we're going to build. So we've got a text area where users are going to be able to type in their code. We've got a button for them to click to run the code. And we've got a little iframe here, which is going to display the output of their code once it has been executed. So let's talk about the logic that we're going to need in order to power this UI. Users are going to type in their code, and we're going to then click the button to run my code. When they do that, we're going to take that code from the text box, and we're going to create a fork of that code. And then we're going to send it off to the subhosting API. The subhosting API is going to spin up a new function, run the code, and return us a URL, which is going to contain the output of that code. We can then display the contents of that URL in an iframe in the UI. Super simple, nice and easy. So let's actually build out the UI itself. We're going to build out a super basic lo-fi React app. I hope that code is big enough for you to be able to read. So this is our entry point. This is our main.tsx file. In here, we're going to create two logical pages for this app. We've got a view page and an edit page. And the reason why I'm separating out these two is just so that we don't spam our subhosting account every single time a user lands on the page. They have to actually click the I want to write some code button. It's just going to save us all money in the long run if we're paying for processing. So we'll set up our routes, and we will pass each page as a prop in the routes. So we can see we've got our view code and we've got our edit code there. The app component itself is super duper simple. It just puts each of those page components that we passed onto the page itself. So let's take a look first at the view code. So this is what they're going to see when they first land on the page. For neatness, what I've done is I've folded away the functions that we're going to be using into this API client.ts file, which you can see included at the top. We'll take a look at that in a minute. But for now, what we're going to do is we're going to present the user with just a block of sample code. So if they want to just test out this functionality, they've got some code on the page that they can already run. We're going to take that sample code, display it in a pre-element, and then we've just got a button that they can click, and that's going to fork the code and set up a new subhosting instance. So next up, let's take a look at the edit page. Now we're getting a little bit more complicated. The font size is getting smaller. On this page, we've got a text area instead of a pre, and this is going to be where our users can type in their code. We're going to take that example code and put it into the text area for them, again, just so they have something they can edit if they want to. And finally, on this page, we have our deployment viewer component. That is literally just an iframe. I won't bother showing you what that component looks like because, yeah, it's just an iframe. Let's instead look at the logic of what this is actually doing. So let's give some space for our logic. We're going to add a few state variables to make the UI reactive. We're going to pass our basic example code into the text area, which is what is happening here. Then we're going to add a deploy changes function. And what this is going to do is when the user clicks on the run button, it's going to deploy their changes to our server-side API. It's going to take whatever code it is, copy it, and send it to the subhosting API, which is then going to run it in a function. Each subhosted function is going to be given its own URL. So the deployment viewer can then just display the contents of whatever is at that URL. The deployment viewer is just a text area that takes a URL. Next, let's look at the API client that we imported. So this is where all the work is being done. This is what is responsible for doing our fetch requests. There's a few functions in here that are important. So first of all, we have this one, which is going to just get that sample code and put it into the text area. Then we have another one, which is going to deploy the code. So if they've edited that sample code, it'll take whatever is in the text area and create a new subhosting API instance and pass that code to that. Finally, we have this wait for deployment function. So what that is going to do is it allows us to poll and see if the function is finished running, see if we're ready to get that URL back. And we do that by calling this get deployment API. But we haven't actually set up any of these APIs yet, so we can take a look at that next. So that was the client side. Now we're going to jump into the server side. When we deploy this application, we're going to need to have something to host it. At the moment, we're using Vite to host us locally. So we're going to create a little server-side app that is going to host our React app when it's deployed. So this is the entry point for that. We're using some middleware called Oak. And Oak is a nice little small package that allows you to do server-side routing. Here you can see an example. Actually, this is kind of interesting. So we looked earlier at the Deno JSON file where we saw our imports. Here you can see another way that you can import dependencies. You can import them directly using a URL. So here you can see we've imported Oak directly. We're saying get it from the JSR package manager. And this is super useful because Deno can actually resolve that at runtime when the script executes, which is going to be super helpful to us later on when we're actually allowing our users to deploy code that could potentially have an import in it. Deno can just totally deal with that. So in this file, all we're doing here is we're creating a very simple HTTP server, and we're using it to serve our static assets. So we've got down at the bottom there, client dist and client public. That is where Vite is going to build our project to. So we're just saying, serve whatever it is that Vite has built for us. And deno.cwd there is just getting the current working directory. So look inside the current working directory, find our client, and then serve the dist in the public. Then we're going to update this to create those APIs that we mentioned earlier. So our get sample, our deploy project, and our get deployment, those three functions we made. Each route is mapped using its verb and its path. I think it's kind of nice and neat. And then the function that actually handles that request. So let's build out these functions finally. So a good example of how Oak Router works. This is a really basic piece of code. This is just getting our little sample code. All this handler does is it loads a file from the system using Deno's file system APIs, returns the body of that as a JSON object, and we need to assign the response body on the context object, and yeah, that's a nice basic Oak example. So let's take a look at something a bit more complicated now. So that is our get sample code. Let's look at what deploy project is doing. This is doing most of the work of this project. So when this API is called, first we check whether it's got a client ID. So if it does, we're going to presume that we're editing an existing project. So this user has already deployed something, already written some code, and we're overwriting that. If it doesn't, we're going to create them a new project. This is just for us. The client's never going to know about this. Then once we've got a valid project ID, regardless of it being new or existing, we're going to work out what content to update the project with. So that's going to happen here. We're going to have a look, see whether we have any code in the text area, or just give it the sample code. And then we are going to presume that the user has posted this code, and we're going to create an instance with this code. Once we've got the project and the ID from the code, we can create this files map. This is a bit overcomplicated. What we're doing is we're sort of treating it like a file system. So we could potentially expand this project to allow them to like upload an entire project to this editor with multiple files in it. At the moment, we're just going to assume that we've only ever got one single entry point, which is the main.ts, but we could make this more complicated in future. We ask the client to deploy the project, passing this code, and then we return the project deployment, and we get that URL from the subhosting. And we're going to take that URL and we're going to pass it back to our iframe. In order to keep our HTTP API headers simple, I've created this Deno Subhosting client file. All this is doing is sending requests to the subhosting APIs using fetch. Fetch is supported natively in Deno. And each of the functions here represent an API call. So we've got our create project and our get project there. We're either creating a new project if they don't have an existing client ID, or we're getting a new project if, no, the other way around. We're creating a new project if they don't, we're getting it if they do. And we validate some status codes, we add some nice TypeScript definitions, and then we return everything. So this is beautiful. This is what our app currently looks like. As you can tell, graphic design is my passion. We can definitely do better than this. You know, we're presenting them with this code that doesn't immediately look editable. The run this code button isn't particularly obvious. It doesn't look great. This looks a little bit better. We've added some styles. The whole project is on GitHub, by the way, so if you want to see any of this code, any of the CSS, you absolutely can. But this still isn't great. Like, we're presenting them with a code editor, but again, the text doesn't look immediately editable, and an editor really isn't an editor without syntax highlighting. Luckily, there are plenty of packages out there that allow you to apply syntax highlighting, because otherwise this would be an absolutely monumental task for us to work through. So I'm using Prism.js, which I'm sure many of you have come across before. It's a nice, easy to use NPM package that we can just import. And what it's going to do is it's going to split up our code into different types, different names, put all of the text into spans, and then apply styles to those spans so that we can color the text. But we have a problem here. We're presenting our users with a text area that they can type in. You can't put spans in a text area and display them and render them. So this presents us with a problem, and I spent a lot of time pondering this, and then I found that somebody else has had this problem before me. So thank you so much to Oliver Gear, who has solved this problem for me. So what we're going to do is we are going to add a code block underneath the text area. We are going to make the text area transparent, and we're going to make the text that is typed into the text area transparent too. We're going to make the text area and the code the exact same height and width and line height, and then we're going to position one on top of the other. So the text area is going to be on top of the code. When the user types into the text area, the cursor is going to move as they would expect in the text area, but the text is going to be invisible. What they're typing is invisible. Then we are going to take what they've typed into that text area and display it in the code block, apply Prism.js to that code block, and allow it to wrap it all in spans, and put the updated stuff all wrapped in spans into the code block so that it looks like it is being syntax highlighted as it is being displayed. Yeah, so that is our finished app. The only thing left to do now is to deploy this app. As I mentioned earlier, Deno Deploy is an online tool. It works like many of your other favorite GitOps deploy tools. You register your GitHub account with it. You tell it which project you want to use. You set up a few little bits of config here so you can give it a project name, tell it where your entry point is, tell it whether there needs to be a build step, anything like that. And then you can literally just click deploy and it will deploy your project for you. The important thing to note here is we need to make sure that it runs our Deno build command that we had set up in our Deno JSON file. That's going to make sure that Vite is going to compile our project into those client dist and public folders that we made earlier so that they're in the correct location so that we can then serve them with that nice little oak HTTP server that we made earlier. So now we pray to the demo gods because here is one I made earlier. So let's have a look. Oh, nope. Let's, oh, good, Wi-Fi, excellent. Nice, okay. So this is the page that the user gets presented with. And at the moment, this is not something I can type into. This is that view code page that we talked about first. So in order to edit this code, the user's going to have to click on the edit this code button. And now we are presented with a text area where we can type in, and we are given this output here where we can hopefully just about see the output of our code. And I can update this here, so I could say hello NDC, and I can run this code. And if the Wi-Fi isn't too painful here, there we go, we can see the updated output of that code. And we can do some more complicated examples. So I'm just going to, here's one I prepared earlier. So I've got a really basic Oak router set up here. And this is where it starts to get super cool. So you can see I am importing that dependency that we used earlier directly, so from JSR. I'm setting up a nice little HTTP server with Oak, and I'm just going to output foo and bar. So now if I run this code, go on Wi-Fi, there we go, foo and bar. So Deno is perfectly able to just import those dependencies at runtime. And it just means that we can allow our users to do some slightly more exciting and more complicated things. If you want to have a look at what is actually happening, and you can see we got all our nice syntax highlighting when I pasted that code in. If we want to completely break this situation, and there we go. So my text area is getting smaller and smaller. There we go. Now we see some problems, but hopefully the user just doesn't do that. And I think it's a nice, for a, what was this, a half an hour creation of a very basic thing that allows your users to do something actually quite complicated, quite complex. You're offering some quite exciting capabilities to your users here. So you can imagine this embedded in some documentation, embedded into your low-code solutions. It just means that you're able to immediately execute other people's code without having to do any of the heavy loading of, how much compute am I going to need? How do I keep us secure? Subhosting is absolutely made for doing this. Everything is deployed within its own little Deno runtime. So your code is entirely sandboxed, is not going to touch anything else on your project. So if you do want to see this code, you absolutely can do. As I mentioned, it's all on GitHub, so please do check it out. If you want to see any of the code that I wrote, you absolutely can. So that QR code will give you a copy of the speaker notes, which also, they have basically everything that I've just said written down for you. If you'd rather read than listen, that's absolutely fine. Yeah, if you do end up using this, please give us a shout. I'd love to know what you use. And if you've not seen the Deno 2 launch video, please check it out because it's hilarious. I have some cute Deno stickers up the front here. Thank you so much for listening, everybody. And yeah, if you've enjoyed this talk, I've been Jo Franchetti. If you didn't, I've been Phil Hawksworth. Thank you so much for listening.